Now in this question, we're given that 2 minus 4i is the root of this equation, z squared plus pz plus q equals 0. And part A, we've got to state the other root, and in part B, we've got to find the values of p and q. Now there's two ways, by the way, that you can find the values of p and q, and in this video what I want to do is show you one way, and then in the next video you can see an alternative way. So for part A, state the other root. Well, this equation has no i's on the outside. You don't see it saying z squared I or pzi. So because it doesn't have any i's in the equation, and we're told that 2 minus 4i is a root, it means that the other root must be the complex conjugate of this one. In other words, all we do is we change the sign against the imaginary part. So for part A, the other root must be 2 plus 4i, the complex conjugate then of this root. Now, for part B then, I said that there's two ways that I can think of doing this, and I'm going to show you one way, and we'll look at it again in another video. So for the way that I'm going to do, I'm going to say let z equal one of these roots. I'm going to pick the z equals 2 plus 4i, only because it's got a plus in it, and it's normally a lot easier to work with pluses rather than minuses, but this would work just as equally if you chose z equals 2 minus 4i. And what we're going to do is substitute this value into the equation and then compare real and imaginary parts. So if we do this, let z equal 2 plus 4i, and we substitute it into our equation, then we're going to have z squared, which is going to be 2 plus 4i all squared, then plus p times z, so that'd be p times 2 plus 4i, and then plus q, and that equals 0. And now if we expand this bracket, we've got 2 squared, which is going to be 4, and then we've got 2 times 4i, which is 8i, and then double that, again that gives us 16i, and then square this last term, that'll be 16i squared, or minus 16, because the I squared is going to be minus 1. Then we've got p times 2, so it's going to be plus 2p, and then p times 4i, that'll be plus 4pi, and then plus q equals 0. So if we now say compare the imaginary parts, let's just do that, compare imaginary parts, what are we going to get? Well, if we look at that, we've got the 16i here plus the 4pi, and that's got to equal 0 because there's no imaginary parts on this part over here. So we've got 16 then plus 4p, we can drop the i's, 16 plus 4p must equal 0. And from this we can easily see that if we subtract 16 from both sides, 4p equals minus 16, divide by 4, and you end up with p equaling minus 4. Now if we compare the real parts, let's just put that in, compare real parts, what do we have this time? Well, 4 minus 16 is minus 12, and then you've got 2p plus q, and what real part have we got over here? Just simply 0. Now we know that p equals minus 4, so now p equals minus 4, so therefore if we substitute it into here, we've got minus 8 here then, minus 12 minus 8 is minus 20, plus that q equals 0, so therefore q is going to equal 20. So when we're finished, we end up with p equaling minus 4 and q equaling 20. So what I'd encourage you to do is have another go at this. Just try z equals 2 minus 4i, substitute it into here, and you should hopefully end up with exactly the same values. Now there is another way of finding P and Q, and I'll show you that in the following video. Okay?